In looking at number 13, we are going to determine whether or not the following scenario qualifies as a binomial experiment. And we have to explain our reasoning and address the 5 points. I've written down the 5 points below. In order for an experiment to be binomial, there have to be a fixed number of trials. Each trial needs to be independent. You have to be able to identify success versus failure. The probability of success has to be constant for each of the trials, and you're looking for the probability of R successes out of N trials. So in looking at this scenario, we have a regular 6-sided die, and we roll it until a 5 appears. So thinking about this right away, if we're rolling the die until we get a 5, this does not represent a fixed number of trials. You might get a 5 on your first roll, you might get a 5, 10 rolls down the line. If you're just rolling until you get a 5, that's not a fixed number of trials. So right away we see that this is not binomial because even that first condition is not met. Let's take a look at the others though, because the directions tell us that we do need to address all 5 of these points. In thinking about whether or not the trials are independent, because we're rolling a die presumably under the same conditions each time, we can say that these trials are independent. We can, in this case, also identify success and failure. Success would be rolling a 5, and failure is rolling anything but a 5. The probability of success is also constant for all of the trials, because the probability of rolling a 5 is 1/6 on a fair die. And then in this case, we're being asked what's the probability that you roll a 5 on the third try. So this is not binomial because, again, we don't have a fixed number of trials, so we can't say that we're looking for R successes out of N trials. So again, this scenario is not binomial, and we knew that right away because it does not meet that first condition.